Today we're going to be doing 1.4, which is perimeter and area in the coordinate plane. When we're talking about perimeter and area, first we're going to be talking about our polygons, so we're going to be able to classify them and know what to call them. And then we will start actually looking at perimeter and areas of those polygons in the coordinate plane. So when we look at polygons, first, most polygons that we think of are like triangles, squares, rectangles, hexagons, octagons, all those good things we should have learned already. And when we look at a polygon, think about if I draw a square on this piece of paper, then that square is a 2D object. Okay, well we've already talked about 2D in geometry. We talked about planes. And so when we look at polygons, polygons are considered a closed plane figure. So obviously my square can't just be open like that. It has to be closed, and it has to be formed by 3 or more line segments, which we call sides. Each side intersects with another side, and at that point we call that point that it makes a vertex. And then one other thing to note is that two sides are with a common vertex, they're going to be no two sides of the common vertex are going to be collinear. Okay, they can't just be a straight line, otherwise it couldn't be two different sides. Okay, in order for it to be two different sides, they have to have some kind of little hinge of an angle there. So you can name a polygon. We name them by just putting the letters in order, okay, in the order that they go around, not necessarily alphabetic order, but in the order from wherever we start at. So I could also call this polygon, like say I wanted to start at C, I could call it C, D, E, A, B. Okay, same polygon. I just decided to start in a different spot when I listed my vertices going around. So then if we go down to the bottom here, another important thing about polygons is to know whether or not they are convex or they are concave. Convex is whenever our sides do not cut off a portion. So if we draw a line through the side, which we know there can always be a line between 2 points, so that line segment of that side, if we extend it to be a line, it shouldn't cut off another part of that polygon. Okay, so that's why this one over here is going to be convex, because it doesn't matter how long I draw this line, it doesn't go through another part of my polygon. Same thing for this side, and I can go all the way around, just like the arrows they have drawn. But then when we look at concave, concave is going to be whenever I do draw that line and it cuts off a portion. Okay, concave is because it has that little part that caves into the shape. Okay, so here this part kind of caves in, and so we call it concave, because when we draw a line through that side, it cuts off a portion. When we draw a line through this side, it's going to cut off part of our shape. So then one more thing to look at when we look at polygons is what we're going to name them. And we have our common names that we call them up through 12. So obviously we know if it has 3 sides, we always call that a triangle. When it has 4 sides, we have a quadrilateral. When we have 5-sided figure, we call it a pentagon. 6-sided hexagon. 7-sided, we call it a heptagon. 8, an octagon. 9, a nonagon. 10, a decagon. 12, a dodecagon, and then we have n, where we call it an n-gon. So that would be like, say my side has 27 sides, my polygon, then I'm going to call it a 27-gon. And that could be for any of those numbers that we don't have a name for it, then I'm going to call it a number-gon, n-gon. So we're going to go ahead and just look at this problem. We want to classify each polygon by the number of sides, and then we want to tell whether it is convex or it is concave. So if we look at our first one, A, we first want to look at how many sides it has. So if I count this side, that's 1, 2, 3, 4. Okay, so if you need to, you can look back at that table. So if I have 4 sides, we call that a quadrilateral. So 4 sides, So we're going to call it a quadrilateral. Then it also wants us to tell whether or not it is convex or it is concave. Okay, so convex means I can draw a line through any of those sides and it's not going to cut off any part of my shape. Concave means it will. So if I draw a line through this first side that I did, well, that one looks good. Then I can go through this other side. It crosses at my line here, but it doesn't cut off part of my shape. It only does because I drew my line crooked. Then I can go to my third side, and this one it does, right? It's going to cut off this section if I go through it. Then I can go on this last direction as well, and this one you can also see it's going to cut off a portion of my shape. So that would mean that this one is concave. Then we can move on to B. B, we're going to count how many sides again. So I'm going to start at this point, and I'm going to go around. So I'm going to go 1, 2, 3, 4, 5, 6. So when I have a 6-sided figure, what is it called? If I go back to my table again, I can look for 6-sided, and this one we call it a hexagon. So 6 sides means it's a hexagon. And then we also again need to see whether or not it is convex or concave. So I'm going to go through my sides. That one looks like it would be good. This one looks like it would be good. I keep going. And if I go all the way around, I should be able to see that none of these would cut off part of my shape. They all are just lines that intersect at a point. Okay, but they don't actually cut off part of my polygon. So that would mean that this one is convex. So now that we kind of know a little bit more about polygons, we can move on to finding their perimeter and area, specifically in a coordinate plane. So in order to do that, first we just need to think about perimeter and area in general. Okay, we should have learned already in previous math classes how to find the perimeter and area of these 3 basic shapes. We have a triangle, a square, and a rectangle. Obviously a triangle, we just call that a triangle. Square and rectangle, remember that these are quadrilaterals. And so we can see our basic formulas that we have underneath here. We have the perimeter. Obviously, perimeter, we know we add all sides. And it doesn't really matter what shape we have. We always add all sides. Just the square and the rectangle, we have kind of little shortcuts where we can multiply. But if we add all sides, it'll still give us the same answer. And then we have our area formulas for each of these. So if we look at our first problem, it says it wants us to find the area of triangle DEF with the vertices D, 1, 3, E, 4, -3, and F, -4, -3. So I'm first going to go ahead and plot these. Remember, you usually want to try to draw stuff out in geometry. I have this grid here. If you don't, just go ahead and draw one up on your paper. Okay, so I'm going to plot. I have D, I have E, and I have F. And then I'm going to want to connect this because I know it's a triangle, it's a polygon. And this problem is asking for the area, but we're also going to change it and we'll find the perimeter as well. So we're actually going to start with perimeter. If I want to find the perimeter of this, I need to know the lengths of each of these sides, right? Okay, so I can name those lengths by being able to say that I know the perimeter would equal the length of DE, which I can just write out as DE, segment DE, plus the length of FE plus the length of FD. Okay, well I have to wonder, well, how do I find the length of DE, FE, and FD? Well, we've learned that. We know how to find it using the distance formula. Remember, distance formula is the square root, and that's going to be our x1. Or actually, it's written x2 minus x1 squared plus y2 minus y1 squared. So I need to solve the distance formula for each of these in order to find their lengths. So if I'm going to look at this, I need to use my points. So if I'm going to start with first, let's do DE. I'm going to go ahead and use D as my x1, y1, and E as my x2, y2. And then I just plug it in. So that means I'm going to have 4 minus 1 squared plus, I'm going to have negative 3 minus 3 squared. I'm going to solve, so I'm going to get 3 squared plus negative 6 squared, so on and so forth. If you need help with the distance formula, be sure you're asking. Don't get behind. So I get the square root of 9 plus 36, which gives me the square root of 45. So if I come over here, I can go ahead and write that DE is the square root of 45. And I could approximate that, and it would be approximately 6.7. Okay, so now I need to do that for all sides. So I'm actually going to have to go back to my distance formula. Now I need to solve for my next side of FE. So FE, and I'm just going to kind of skip through. I'm going to show you what these steps look like, but you need to pause your video to actually write them down. So here are the steps that I worked for distance formula for FE. So if you need to, go ahead and pause, write down, or check your work if you worked it on your own. So I'm going to go over here to FE, and I'm going to write down that I ended up getting 8 exactly. And now I'm going to do the same thing for FD. So again, pause now if you need to see this work, because then it's going to be gone. So now here I've worked the distance formula for FD. So now again, I'm going to put it over here. FD, I ended up getting the square root of 61, or approximately 7.8. Now I'm going to go ahead and I'm going to erase this, and now I can actually look at finding the perimeter again. So going back up to that step at the top. So now I actually know my side lengths, so now I can just plug them back into this perimeter formula that we have up here. So I have equals, well, DE I found was the square root of 45, plus FE I found was 8 exactly, plus FD, which is the square root of 61. I can go ahead and plug that in and try to get that answer, or I can also just do these decimals and get the approximate answer that way as well. So DE, I ended up getting 6.7, plus FE, I got 8, plus FD is 7.8. And either way that you plug this in, you're going to get approximately 22.5 for your perimeter. Okay, and that's just a rounded answer, so 22.5 would be my approximate perimeter for triangle DEF. So then we also want to find the area. Okay, well, area for a triangle is 1/2 base times height. Well, I could consider this to be my base of 8. It's a nice little round number there, so I'm going to use it. But then I need to find my height. Well, if I look, D is my highest point on that triangle from that base. So I'm just going to go draw it straight down to the base. And then I just need to be able to find my height. Well, if you'll notice, that height is exactly on a line in this triangle. So I can just count my squares. So I have 1, 2, 3, 4, 5, 6. So that means I have a height of 6. So now I just need to put it in my formula. So for a triangle, I have area is equal to 1/2 base times height. Like I said, my base in this case is going to be my 8. And then my height is that 6 that I just counted. So then I just solve, and when I solve this, I'm going to get 24. So my area would be 24. So then we're just going to have one more example. This example is just kind of a little bit more real life. You're building a shed in your backyard. The diagram shows the 4 vertices of the shed. Remember, those are our points. Each unit in the coordinate plane represents 1 foot, so we want to find the area of the floor of the shed. So maybe we want to know how much plywood we're going to be putting down there, or we're going to paint it. But for some reason, we need to find the area. So if we're looking down from a sky view, this is what our floor would look like. And so we just need to find area. Well, for a rectangle, we can do area is equal to length times width. But more commonly in geometry, we're going to start seeing this as base times height. So if I look, I can use my base. So I'm going to consider this K to J to be my base. So I'm going to be this my little b. And then my height, I can look at from K to G. Well, since this rectangle is so nicely on the lines for us in this coordinate grid, we don't actually have to use distance formula this time. We can just count them. So if I go 1, 2, 3, 4, 5, 6. So my little b is going to be 6. If I go up, 1, 2, 3, 4, 5. My height is going to be 5. So I plug these numbers in. I get 6 times 5. So that would mean my area is 30. Okay, but remember we do have a label on this one. So if each if each square is a foot, then that means that's going to be my label is feet. But when we do area, it's not just feet, it's feet squared. So in this case, the area of the floor of the shed would be 30 feet squared. And that's all that we have.